All right, so we've got a wall and there's a box against the wall and it's being held there because somebody's pushing up on it like this. Let's call that force just F. So, and it says that this force is 28 degrees above the horizontal. So if the horizontal is here, this angle right here is 28 degrees. So now we just need to draw the free body diagram. Pause the video while you try it on your own paper. We have mg pointed downward. We have the force that they're pushing with, that F, is going to go exactly the way it looks in the other picture. Then we have the normal force. The normal force is perpendicular to the surface, in this case the wall. So since the wall is vertical, the normal force is horizontal. So there's the normal force. And then we have friction. Friction is going to be parallel to the surface, so in this case vertical, and opposing the motion if it would move. And I think if it would move down, so the friction is going to be upward. So there's the friction. So now that we've got our free body diagram, we can put our axes in. I'm going to go ahead and put them the regular way, even though it's going to look really weird. There's my x-axis. Here's my 28 degrees. And here's my y-axis. There. So my x equation looks like normal force to the right, so that's positive. And the only other thing that is horizontal at all is this F force. So we're going to go minus, because it's to the left, F cosine. It's cosine because it's the x equation, and the angle 28. And if this box isn't moving, this has to be equal to 0. Now for the y equation. We have two vectors flat on the y-axis, the f and the mg. So I'm going to put those in, f positive because it's up, mg negative because it's down. And then we have the vertical component of this pushing force F. We know that if we have F cosine 28 in the x equation, we have to have F sine 28 in the y equation. Then we just have to decide whether it's positive or negative. And it's upward, so that's a positive in the y equation. And that has to be also equal to 0. And we know that friction is equal to mu times the normal force if this would be true if it were sliding. And this we would use mu sub k, but this problem says that the box is not sliding. It says it slides down unless you push with enough force. So it looks like we are having just enough force that we have static friction. So we're going to say F is equal to static friction times the normal force. And now all we have to do is put all of these equations together to solve the problem. So I'll take, we're looking for the mass of the box, right? So we can plug the friction equation in for the friction. We can plug this normal force in for the normal force there, and then we'll have an equation here that we can solve.